Welcome to Your Math Explained, where we make math simple and clear. My name is Angela. In the last video, we learned how to get exact sine, cosine, and tangent values using special triangles and axis angles. Today, we're going to take those values and plot them on a graph. This is how the famous sine, cosine, and tangent curves are built. So let's start with the graph of sine x. So using the two special triangles and the axis angles that we covered in the previous video, you can fill in this table here. If you want to give it a try first, feel free to pause this video and fill those in. If not, you can just follow along with me. So we're going to start with the axis angles, which are 0, pi over 2, pi, 3 pi over 2, and 2 pi. So sine of these values are going to be 0, 1, 0, -1, and 0. And now, using our special triangles, we know that sine of pi over 6 is 1/2. Sine of 5 pi over 6, so that one will have a reference angle of pi over 6, and it's in quadrant 2, so that'll also be 1/2, because sine is positive there. Sine of 7 pi over 6, that also has a reference angle of pi over 6, however, that one is now in quadrant 3, where sine is negative, so that's going to be -1/2. And sine of 11 pi over 6 is in quadrant 4 with a reference angle of pi over 6. So that is also -1/2. And now we're ready to graph our sine curve. And just like how we filled out the table with the axis angles first, we're going to plot these points first. So that means we're going to have our 0, 0, pi over 2 and 1. So pi over 2 is right over here. So that'll be this point up top. Pi, comma 0, so that's right here. And then 3 pi over 2 is right here. And that has a y value of -1, so that'll be down here. And then the last value here is 2 pi, comma 0, which is right here. Now pi over 6 is 1/3 of pi over 2, so that'll be here. 5 pi over 6 is right here. 7 pi over 6 is down here. And then 11 pi over 6 is right here. And now we're just going to connect those dots, and that'll give us our sine graph. So it looks more like a wave than straight lines. So when you draw it, make sure that it is curved and not straight lines. And even though our graph is from 0 to 2 pi, we know that if we were to extend that to the right or to the left, the pattern is going to repeat. So we can actually use this pattern and fill our graph on the left side. So that would be down here, here, up here, and then we don't have space to go more towards the left, but the curve should look something like this. So now let's go ahead and talk about the properties of the sine curve. The domain is just all real numbers because x can be any value and it won't break our function. So that would be x is an element of all real numbers. The range is all the values that y can be. And looking at our graph, we can see that it is in between -1 and 1. So therefore our range is -1 is less than or equal to y, which is less than or equal to +1. The y-intercept from the graph we can see is y is equal to 0. Now the x-intercepts from our graph, we can see we have -pi, 0, pi, and 2 pi. However, that's because we've only drawn the graph in the segment. We've said that the domain for the function y is equal to sine x is all real numbers, which means that this pattern is going to continue on forever. And from what we've drawn so far, we can see that it's going to cross the x-axis at every multiple of pi. So therefore, we can write our x-intercept as n times pi, where n is an element of the integers. Next, we have our amplitude. So the definition of amplitude is the distance from the maximum of the graph to the midline. So looking at our graph, we can see the midline is at y is equal to 0 because half the graph is above it and half of the graph is below it. And the maximum distance happens right over here. So the amplitude is this distance right there. And because we know that the maximum is 1 and our midline is 0, then our amplitude is going to be 1. And then lastly, we have our period. So period is how long it takes for the graph to start repeating. So then going back to our graph, we can see that we start at the origin, we go up to 1, come back down to 0, goes down to -1, and then we return back to 0. So that's our full cycle from 0 to 2 pi. And what's going to happen is that that pattern is going to continue to repeat. So it'll continue going like this. So therefore, our period is going to be 2 pi. The next curve we're going to look at is the graph of cosine x. And we're going to follow the exact same process. And again, if you want to try it yourself, feel free to pause the video and fill in this table. So we're going to start with our axes angles. So that means cosine of 0 is 1. Cos of pi over 2 is 0. Cos of pi is -1. Cos of 3 pi over 2 is 0. And cos of 2 pi, we're back to 1. And then now our special triangles, so this is going to be 1/2, -1/2, -1/2, and 1/2. So usually when we graph these two functions, the details expected are usually the 5 main points, which are the 5 axes angles. We don't focus so much on the values that we get from the special triangles. So the main points that you need to remember are the 1, 0, -1, 0, and 1 for our cosine function. So we start with 0, 1, pi over 2, 0, pi -1, 3 pi over 2, 0, and 2 pi, 1. Adding in the special triangle points, so that would be here, 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 and here. Now we can go ahead and connect these dots in a curve. So notice how cosine has the same shape as our sine curve from earlier. It just has a different starting point. And then we might as well fill it on the left side as well. So that'll be here. And now, just like what we did with our sine graph, we're going to go over the properties of our cosine function. So our domain here is, again, x is an element of all real numbers because we know that this pattern is going to continue and x can be anything. Our range is the same as sine x because we have a maximum of 1 and a minimum of -1. So our range is going to be y is in between -1 and 1. Now our y-intercept is now equal to 1. And our x-intercepts, let's go ahead and write them. We have pi over 2, 3 pi over 2. This is -pi over 2, and this is -3 pi over 2. So we can see that we still cross over the x-axis every pi, but it's shifted by pi over 2. So therefore, our x-intercept, we're going to write it as pi over 2 plus n pi, where n is an element of the integers. Our amplitude, recall that that is the distance between the maximum of the graph to the midline. In this case, is the same because our midline is y is equal to 0, and our highest point has a y value of 1. So our amplitude is still 1. And our period, even though the graph is shifted compared to the graph of our sine function, the period is still 2 pi. Because we can see that every 2 pi, our graph is going to repeat. We go from the highest point to the highest point, and then it happens all over again. Now, the last function we're going to cover in this video is the graph of tangent x. Now, this one is going to look very different from the previous two graphs. But let's go ahead and fill in our table first. So tangent of 0 is going to be equal to 0, but tangent of pi over 2, from our axis angle, we know that it is undefined. Tangent of pi is again going to be 0, but tangent of 3 pi over 2 is again undefined. And then finally, tangent of 2 pi is back to 0. Now for our special angles, tangent of pi over 4 is 1. Same thing for 3 pi over 4, but because it's in quadrant 2, this is -1. And tangent of 5 pi over 4 is +1 because we're in quadrant 3. And then tangent of 7 pi over 4 is -1. So let's go ahead and plot those. We would have 0, 0, and where it's undefined, that would be a vertical asymptote. And we denote that by drawing a vertical dotted line. So that just means our graph cannot cross this line. And then at pi, it is again 0. And then we have another vertical dotted line at 3 pi over 2. And then at 2 pi, it's 0 again. So now putting in our other value, we would have, this is 1, this is -1, and then here we're back to 1, and then here we're back to -1. And since we know that this pattern repeats, we're actually going to go ahead and put in the other asymptotes, which is going to happen at -pi over 2 and -3 pi over 2. And then those are going to be zeros. And we have -1, +1, -1. The tangent curve actually looks something like this. So because we can't cross it, it goes to infinity, goes down, and then goes down to -infinity. So then we would have a graph that looks like this. And then, in fact, they all look like that. So we're just going to draw one more back here. So this is what the graph of tangent x looks like. Now let's go ahead and write down our properties. So the first one is asymptotes. So we can see that these vertical lines happen at intervals of pi, but shifted by pi over 2. So meaning our asymptotes are going to be x is equal to pi over 2 plus n pi, where n is an integer. So why are we writing this down? We're writing this down because these asymptotes are what our x cannot be. So meaning our domain is going to be x cannot be equal to pi over 2 plus n pi, where n is an element of the integers. Our range here, we can see that y can take on any value because look in between two asymptotes, we can see that it stretches all the way to infinity and -infinity. So our range here is going to be y is an element of all real numbers. Our y-intercept happens right at the origin, so that's 0. Our x-intercepts happen at every multiple of pi. So that's going to be x is equal to n pi, where n is an element of integers. And then finally, our period, recall that that means how long it takes for the pattern to repeat. We can see that the pattern repeats every pi. So therefore, our period here is pi. So a quick note here is that the period of tangent x is different from sine and cosine. Tangent has a period of pi, whereas sine and cosine both have a period of 2 pi. And now let's do a quick recap of everything that we covered in this video. We used our known exact values from the last video and turned them into graphs for our trig functions. We learned the main features like domain and range, as well as a couple of new terms like amplitude and period. And we also saw where the graphs are undefined for our tangent function. These 3 graphs are the building blocks of all trig modeling you will see in the later lessons. And now it is your turn to give this a try. Can you graph the function y is equal to sine of x and y is equal to cosine of x by heart? Don't reference any material. Are you able to come up with the correct 5-point summary? Leave your answer in the comments below and let us know if you'd like to see more content on graphing trig functions in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.